Question 1.3. Solve for x minus 1 bracketed times x minus 2 bracketed smaller than 6. Now, we first notice that we're dealing with an inequality. We also notice that we do not have the equation in standard form for a quadratic. And remember, that looks like ax squared plus bx plus c, and in this case, smaller than 0. So first, because we can't do anything with this now, let's try to get it into this form. And we will do that by expanding out the brackets. So let us do that. X squared minus 2x minus x plus 2 is smaller than 6. And now this is just algebra. Minus 2x minus x is minus 3x. 2 minus 6, bring it over to the other side, is minus 4. Smaller than 0. Now this is something we can work with. Now what I like to do is I forget about the inequality sign for now, because we're trying to find for what x's this equation will always be smaller than 0 in the quadratic equation. Quadratic graph, sorry. So I like to first think, okay, let's find the roots where our graph is equal to y equal to 0. And then we'll deal with the inequality. So let's do that. That means we're going to have to factorize this. Now we can use our solver calculator to find the roots, or we can use the quadratic formula, or we can use factorization, and that's what I'm going to do here. So first, I notice we're dealing with a negative for the constant. So that means we're probably going to have different signs. So we know that our quadratic will look something like this when factorized. Now I'm putting an equal here because first I'm dealing with the roots of the quadratic. And now we continue. We break up the factors of minus 4 to find what they will be multiplied with to get minus 3x. So the factors of 4 are 4 and 1 and 2 and 2. And because we have no coefficient for the x squared, we don't have to worry about taking him into account. So how can we make minus 3x from these factors? Well, we could say minus 4 plus 1. So let's see if we can put that into here somehow. So if I said minus 4 plus 1, then we would have x squared plus x minus 4x minus 4. And that's exactly what we would get if we were to expand out this expression. So now we can continue and say for what x's we will always get 0. That will be x equal to 4, x equal to minus 1. Now we draw a graph to visualize where, because remember we're dealing with an inequality, we're not finished, where this expression will be smaller than 0. So let's draw our graph. We don't have to go precisely in detail, for example, the y-intercept and such, we just need a rough sketch. So, will our graph look happy or sad? Well, remember, we can tell that by the sign of the coefficient for the x squared. And we have a plus, so therefore, our graph will be happy. If it was minus, it would be sad. So let's just draw that rough. And our roots are 4 and 1. So our graph actually doesn't go to the negative x region. So it will look something like this. 4. Oh, I apologize. It's minus 1. I thought that looked wonky. Minus 1. There we go. So our graph will indeed look like this. And then we will have a 4 and a minus 1 for the roots. Now comes the inequality. It states for what x's will this expression be smaller than 0? In other words, where is it negative? So let's see. That will be in the region I highlight now, under the y-axis. So how can we represent that region? Because remember, above the x-axis is positive, below the x-axis is negative. So how can we represent that region? Well, let us simply write x will be an element. Now we'll deal with the brackets now, of minus 1 to 4. Now, how do we know if it's a square bracket or a curly bracket? How do we decide that? Well, we look at our original expression. Is it inclusive or exclusive? It's exclusive. It's not smaller or equal. So therefore, we will be dealing with curly brackets. And that is the problem solved.